All right, this is Unit 3 from College Board, reviewing. Again, this is mostly derivative practice and review. So f at x equals x squared subtract 3 to the fourth. And what's the derivative at 1? Step 1 is to take the derivative. That's going to be the power rule with the chain. Subtract 1 to the exponent. And then the hook is the derivative of x squared subtract 3, which is 2x. So altogether we have 8x, x squared subtract 3 to the exponent 3, and then we're going to plug in 1 and get our answer. So that's 8. That's negative 2 squared. So I get 8 times 4. I get 32. And you have your answer. Number 2. Again, my goal is to keep this under an hour, so I'm going to even do better than I did in the first videos. If f and g are twice differentiable functions, g at x equals e to the f at x, and the second derivative is h at x times e to f at x, then what does h at x equal? So what I'm going to do. So first of all, I'm going to take the derivative of g at x. That's e to the f at x, and then the hook would be f prime at x. Now, the second derivative, if I look at it, so I'm going to take the second derivative from here. So this is going to be the product rule. The first times the derivative of the second, that's the second derivative, plus the first. So the first times the derivative of the second plus the second times the derivative of the first. Now, I know this second part, e to the f at x, f prime at x. And my goal again is to figure out this, which could match here. So let's see if I can make some connections here so I can replace some stuff. So I do know that the second derivative is h at x times e to the f at x. I know that. So these are the same, and then I still have this. Now I'm going to factor out an e to the f at x. So both of these have an e to the f at x. So I have the second derivative of f at x. And then I have the first derivative, but it's the first derivative times the first derivative. It's the same thing, so that's actually squared. So if I divide out e to the fx, I get the second derivative plus the first derivative squared. There it is right there. So that answer is D. Number 3. Number 3, can you take the derivative with exponential and a trig? So the rule for E is to copy it, and then the hook comes from the exponent. So the derivative of tangent squared x, so I want you to think of that as tangent x squared. The derivative of that would be 2 times 1 in front, that's a 2. Then tangent x, subtract 1 to the exponent, that's 1. And then the derivative of tangent is secant squared. So I got 2e to the tangent squared. Then I have tangent x, and then the derivative of tangent x is secant squared. Let's see if I can find it. See if I can remember all those lines and see which one would match with it. So these are wrong. So which one would match between that in terms of what I just wrote down? So I think this is the one, right? That matches it. 2 tangent x secant squared and so on. Perfect. Number 4. If f at x equals e to the 1 over x, then what's the derivative? So the derivative of e to the 1 over x is e to the 1 over x. and then the derivative of 1 over x. Think of that as x to the negative 1. So negative 1 times 1 in front would make it negative. Subtract 1 to the exponent, and it would be negative x to the negative 2. And then which one would match that? So recognize that a negative exponent means it goes in the denominator. So this is what we're looking for. It's negative, and x squared is in the denominator. Done. So that matches with A. Number 5, y equals sine cubed x. So I'm going to write this as sine x cubed, and then can you take the derivative of that? That's 3 sine x, and then it's squared, and then the derivative of sine x is cosine x. And there it is. And that 2 could be in the middle. Let's see which one matches. So the ones that would match, the only one that match right here, right, is this one right here. And I'm crossing out answers that don't match. Number 6. Take the derivative of arctangent. How do I do that again? So here we go. You ready? So what I see, e to the 2x, the derivative of that, which is e to the 2x, and then the double hook, the derivative of 2x is 2. That's the numerator. Then it's 1 plus, and whatever I see, you square it. So it's e to the 2x squared. Now, exponent laws, you'd multiply it together. So that would be 4x if we're looking for it. So 2e to the 2x, 1 plus e to the 4x. And I found it. Number 7. If f at x equals cosine 3x, and of course you don't have to go at my pace. You can go at your pace. Press pause. But I'm going to make sure it's there. And again, I'm committed to under an hour. So I should stop talking about, get my work done. The derivative of cosine is negative sine, and there's an extra hook. So the derivative of 3x is 3, and it's negative. When I plug in pi over 9, I'm going to simplify it. So that's negative 3 sine pi over 3. All right, my unit circle, that's a 60-degree reference angle. The y-coordinate there is root 3 over 2. So this is negative 3 times root 3 over 2. Negative 3 root 3 over 2. It's E. Number 8. Y equals, and that's a symbol for inverse. They should really use the word arc sine. That means the same as arc sine. You could, I guess, see either one. So if that's arc sine, then the derivative, what you see, the derivative of 5x is 5. It's square root 1 subtract. And then what you see, you square. That matches with E. Number 9. Can you take the derivative implicitly? So the derivative of 3x squared, 2 times 3 is 6. Subtract 1 to the exponent. This is going to be a product rule. The first times the derivative of the second. So whenever you're taking the derivative with a y in it, it needs the hook y prime. The derivative of y is 1, but the hook is y prime. So the first times the derivative of the second plus the second times the derivative of the first. The derivative of y squared is 2y, but it needs the hook y prime, and the derivative of 1 is 0. So next, if it doesn't have a y prime, so that would be 6x and 2y. So if it doesn't have a y prime, it goes to the other side. And I'm also going to factor out a y prime. So I'm going to factor it out of the 2x. I'm going to factor it out of 2y. And again, I subtracted 6x. So subtract 6x, subtract 2y, factor out a y prime from each term, and then divide. Most likely you're going to have to reduce this down. So 2 goes into everything evenly. So if you divide everything by 2, you get negative 3x minus y and you get x plus y. So this is what you get when you reduce it down. Oops. So that's what I'm looking for. You could also have the negative in front. So they just put they factored out the negative in front, and then that matches it. Number 10. You're given a table of values. And so the table above gives values of f, f prime g, and g. I don't know what that symbol, I think that's g prime. For selected values of if h at x equals that, then what's the value of h prime at 1? So what they're doing here is, do you know the chain rule generically? So what's the derivative of h generically? So that's the derivative of the outside times the derivative of the inside. That's the generic chain rule. And then plug in 1 and then look off the chart. So first of all, g at 1, look off the chart, and it's 3. G prime at 1, that answer is negative 2. And then what's f prime at 3? So look for 3, f prime, that's 7. So it's 7 times negative 2. And you have your answer. Number 11, let f be the function that, let g at x be the inverse of f, where g at 3 equals 1. What is the value of the derivative at 3? Okay, so just maybe a little chart would help us here. Understand that for g at x, the point is 3, 1. So if they're inverses for f at x, the point would be 1, 3. The derivative at 1 and the derivative at 3, they are reciprocals. So I'm going to take the derivative and plug in 1, and then whatever the answer is, I do the reciprocal. All right. So the derivative of f at x is 3x squared. There it is, plus 2x plus 1. Then I'm going to plug in 1 and get an answer. So I took the derivative. I'm going to plug 1 in. That is 3 plus 2 plus 1. I can do that. And then that means this derivative at 3 must be the reciprocal, of what I just did. So the reciprocal of that, the answer is 1/6. That's the relationship there. Same kind of question again. So this would be a great one to pause and try on your own, because it's just like the one we just did. So can you do that for me? Pause it, try it, and then let's see if we did it right. So I'm going to organize it. Again, the point on G is 2, 1. So if they're inverses, then for f at x, you inverse it, and it's 1, 2. The derivative of f at x would be 3x squared plus 1. Plug 1 in, and you get the answer 4. And therefore, the derivative at 2 would be the reciprocal of that. That's the relationship. So the answer is 1/4. Number 13. You're given a table of values for number 13. The table above gives selected values for differentiable and increasing function and its derivative. If g is the inverse of f, so this is another inverse question. What's the value of that? So for g, the x value is 3. For f, you would do the inverse of that. So now the y value is 3 when you inverse it. Look off your chart. So when the y value is 3, the x value is 1 for f. So now I have the values that I need. The derivative at 1, is 4. So therefore the derivative at 3 is the reciprocal of that, and you have your answer. Number 14, another inverse question. The table above gives selected values of a differentiable and decreasing function f and its derivative. If f prime is the inverse of f, what is the value? And it gives it to you here, the derivative of the inverse. So they go f1 is the inverse at 2. So let's just understand this. If that is the inverse, then working backwards, that x value is actually the y value of the actual function, f at x. So if this is f1, the x value, then inverse it. So if I look off here, 2, that gives me the answer 1 for the x value. So if I find the derivative at 1 off the chart, the derivative at 1 is negative 8, then that means the derivative of the inverse is the reciprocal of that. Make sure you keep the same sign. It's negative 1/8. And you have your answer. Number 15, f at x, find the derivative at 0. So honestly, this is a simple power rule with a chain or hook connected. So I'd like you to try it. Honestly, you can do this. 2/3 times 1 in front, subtract 1 to the exponent. Remember there's a hook. Then plug in 0. Then press play. Or let's say I start it for you and then you realize, oh, I understand now what I need to do. Remember, an easy way to subtract is to go 2 take away 3. And then the derivative of the base is 2x minus 2. So take the derivative, then plug in 0, and tell me the answer. So the negative exponent just means reciprocal. So it's going to stay negative 1. So I get a negative. I get 4/3. So again, it's going to stay negative 1 to any odd exponent. So cube root is odd. Will stay negative. If it was an even exponent, then it would change to a positive 1. So the answer is positive 4/3. 16. F at x equals that. Then the fourth derivative of f at x equals 0. Wow. So the first, fourth, and so on. So I think the answer is going to be 0. But if you continue down, that the exponent here there might be a pattern. So that's 8. So it's 3 times 8. That's 48 times 2. Right? 48, 48. And then times 2. And now what's going to happen, if I go one more, what's the derivative of this? And then plug in 0. So right now it's 2 times 96. So that's 180 and 12. So I get 192, and then you have to Yes, Grace?
I have a work over too.
Aw, that's good to tell me. But right now I need to get my work done.
Bye-bye.
So 96 times 2, 96 times this. I'm going to tell you this right here, 96 times 4, I hope this works, is 24. I get 384. That's 384x. I don't care about the constant because the derivative of any constant is 0. So the derivative of this would just be 384. That's the answer I get. Let's see if I turn the page, I get 384. Oh, I feel better about it. All right, it got me nervous. Number 17. Can you take the derivative implicitly and plug in a point? Let's do this. So the derivative of e to the x is e to the x. The derivative of negative y is negative y prime. This is the product rule. The first times the derivative of the second, don't forget the y prime, plus the second times the derivative of the first, which is 1, so I don't need it. The derivative of e squared is 0, and the derivative of negative 18 is 0, because they're constants. I want to get all the y primes together. All right, so I'm going to add y prime to the other side. I just combine them together. I'm going to subtract y cubed. And I just want to get y prime by itself. So I'm going to factor out a y prime. And then I'm going to divide. At this point, we're going to plug in 2. So 2 for x and 2 for y. So 2 cubed is 8. 2 for x and 2 for y. So 3 times 2 is 6 times 4, I get 24. And that's the answer I get. E squared minus 8. 24 plus 1. Well, that's 25, isn't it? So the answer is C. Number 18. Again, I'm going to take the derivative implicitly. So this is 6x. This is the product rule. X, y together is the product rule. The first times the derivative of the second plus the second times the derivative of the first. The derivative of y squared is 2y, but it needs the hook y prime. And the derivative of 2 is 0. Then the y primes are going to stay. But I'm going to subtract 6x, and I'm going to subtract 2y. And then I'm going to factor out a y prime. And then divide. Now, it might be helpful to reduce it down, so I'm going to divide everything by 2. And then I'm going to use the point, find the value of dy by dx when x equals 1. So when x equals 1, let's see if y is in the answer or not. Okay, so I got x equals 1. How am I going to find y? Is I got to plug it into here. So if x is 1, that means I have 3. If x is 1, I got 2y. And y squared is equal to 2. So I got a quadratic equation to solve. Y squared plus 2y. Subtract 2. 3 take away 2. That's 1. So if I factor this, y is equal to negative 1. That's the answer. So I actually have to do some work to figure out the y value. So now I have the x and the y. So y and x, that's 1 and negative 1. Well, guess what? 1 and negative 1 makes it 0. It's undefined because we have a 0 in the denominator. So the answer is E. Number 19. If y equals ln that, then what's the derivative? So the derivative of ln is what you see is in the denominator, and then the derivative of what you see is the numerator. That's 2x plus 2y, but there's a y prime involved because you're taking the derivative with a y involved. All right, so next I want to get all the y primes together on one side to be able to rearrange this algebraically. So I have y prime times x squared, y prime times y squared. So I just multiply by x squared plus y squared, and then if it has a y prime, it's going to all come together. So I brought them all together. I subtracted two y primes. They're together. Then factor out a y prime, and you have x squared plus y squared minus 2y. And then to get y prime by itself, you divide, and now you plug in the values that you have. So I divided by x squared plus y squared minus 2y. The point we're going to use is 1, 0. So plug in 1 for x, and then 0 for y. I get 2 over 1, or 2, and there it is. And you have your answer. Number 20, let f and g be inverses that are differentiable. F is negative 5, 7. So I'm going to write that down. Negative 5, 7. So the inverse is g would be 7, negative 5, just so I know. The derivative at 7 is 3. So if I inverse it, the derivative at negative 5 is 1/3, because they're reciprocals. In the answer there. So the derivative at 3, don't know. And don't know. The only one I know, it says which of the following statements must be false. So this is true. The derivative at negative 5 is 1/3. The derivative at 3 is negative 1/3. And the derivative at 7 is 1/3. Which one must be false? So I know that 2 is true. The derivative at negative 5 is 1/3. So which one must be false of what's left over? Let me just double think through here again. Which one must be so false of the two that are left? The derivative of g at 7 is 3. So which one must be false? So I'm thinking through. I know that's true. The derivative of f at negative 5 is 1/3. So the derivative at f at 3, or the derivative at 7. So my gut is going right here, or 1 and 3, but I'm thinking 3. I'm not even gonna. Well. Okay. I think I get what I'm doing here. So if the derivative of 3, so if f at x was 3, I don't even know what g is, but if that's the case, then the y value for g would be 3, which is this one. So therefore, this is describing that relationship. So this one must be false, because that answer should be 1/3. Right? No. Which one must be false? So I know which one is true because I see the reciprocal relationship. Which one must be false? So I know it's not 2. So is it 1 or is it 3? Let me just keep thinking through this. So the other one... All right. So the other one, the derivative for f at 7, if I did the reciprocal, then for g, all right. I'm just going to go for it. So I'm going to say both D, 1 and 3 are false, because I know the middle one is true. Must they be false? I can't defend my answer right now as I think through it. All right, number 21. Which of the following increasing function, again, that's a symbol for inverse of the derivative of 20 equals 1/5. For which of the following increasing functions does the inverse of that? So if that is the inverse, and the derivative is that, so the derivative at that value is 1/5. So whatever that, or the derivative of that is 5. So this is what I'm looking for. So the x value is 20, so the inverse is this. The derivative of whatever that is would equal 5, the reciprocal. So when I look here, it can't be a, because the derivative would equal 1. So if I make it equal to 20, which one would give me a derivative that could equal 5? I'm going to go for it. I'm going to make this one equal to 20. So 0, this one has an answer of 0 and 20. So the derivative of that is 3x squared plus 5. Ugh. And the derivative at 0 is 5. What a weird, right? Kind of working backwards and figuring it through. And so I get the answer B that matches it. All right, number 22. Let f at x equals x cubed and g at x equals x over x minus 1. If h is defined this way, which of the following gives a correct expression for the derivative of h? So the derivative of h, this is the chain rule. That's the derivative of the outside times the derivative of the inside. So that's the correct notation for it. And then if I plug in what the values are, so for this one, f at x and g at x. So let's first of all do that. So f is on the outside and g is inside. So this is what it would look like. So x cubed is the outside function, and this is inside. So take out the x, put this in for x, and now it's f composed by g. And now what would the derivative look like? And then it would just be the quotient rule. And I think I just did this one. Right? 3 times x minus 1 squared times x minus 1 minus x. So yeah, I did it. So that answer is C. Turn the page. In number 23, let f be the function defined that way, where h is a differentiable function. Which of the following is equivalent to the derivative of f with respect to x? So the derivative here is copy it times the derivative of the exponent. So which one would be e to the h times h prime at x? And there it is. You could multiply in any order. 24. That's arctangent, just so you know. So arctangent, the derivative of what you see is the numerator. The denominator is 1 plus, and you square it. And that matches with D. 25. This one does say arctangent, and it's a limit question. So if f at x equals arctangent, and they give you this is the definition of a derivative at a point. So in other words, take the derivative, that's what this is. This is the quotient formula. This is the original derivative formula at a point. So all it's saying is take the derivative. So for arctangent, this is the derivative. And then plug in root 3. So if you plug in root 3 squared is 3. So this is just 1 over 4. And you have your answer. 26. Take the derivative of ln. So what you see is the denominator, the derivative. Now be careful here, because we need to get the y primes by themselves. So we're going to cross multiply here. So we got 3x y prime, 4y y prime. That's just by multiplying. And then we need to get all the y primes together. So we got 3x y prime. We have 4y y prime minus 4y y prime. Is that right? For y prime minus 4y prime. Totally different terms, all right? Just took a second there. And then I just have 3 by itself. Factor out a y prime, and you have 3x plus 4y minus 4, and then divide. So 3 over 3x plus 4y minus 4. So 3 over 3x plus 4y minus 4. Done. That's D. Number 27. Take the derivative. So e to the y would be e to the y, but it needs the hook y prime. E to the y squared is e to the y squared. That's 2y, but needs a y prime. The derivative of x is 1, and x cubed is 3x squared. Now, factor out a y prime. And then divide. All right. And then they say plug in the point 0, 1. So if you plug in the point 0, 1, if you plug in 0 for x, you get a 1 in the numerator. If you plug in 1 in the denominator, you get e to the 1, which is e. You get minus 2 e to the 1, which is e. So 2 times 1 is 2. 1 squared is 1, so that's e to the 1. So it's minus 2 e to the 1. Combine like terms. And I get 1 minus 2, 1 over negative e. That's A. 28. What is the slope of the line tangent to that? Slope of tangent means derivative. So the derivative of arctangent, the derivative of what you see, so the derivative of 4x is 4, then it's 1 plus, and then you square it, and then at, what is it, 1/4. So now plug in 1/4 and then answer it. So this is 16. These cross out. That leaves me with 1. So it's 4 divided by 2. 1 plus 1 is 2. 4 divided by 2. So I get the answer 2. So the answer is A. 29. The slope means take the derivative. So the product rule, the first times the derivative of the second. The derivative of x is 1, so this is y cubed, plus the second times the derivative of the first, and it needs a y prime. Same thing here. The first times the derivative of the second, plus the second times the derivative of the first, sorry, that's 2y, and it needs a y prime. And then the derivative of 6 is 0. So now this is what I'm going to clean up. So combine like terms. Keep the y primes together. Subtract y cubed. And subtract 2xy squared. So they're now on the other side. And then factor out a y prime. And then divide. I get negative y cubed minus 2xy squared over 3x plus 2x squared y. And then it says plug in the point 2, 1. So if I do that, 2, 1. So if I plug in 2, I get 6. If I plug in 2, I get 8. Is that right? 6 and 8, that's 14. In the numerator, if I plug in 1, I get negative 1. Here, I get negative 2 times 2, that's 4, so that's negative 4 times 1, that's negative 4. I get negative 5 over 14. And there you go. 30, what's the slope of the line tangent? That's another word for derivative. The derivative here, what you see is the denominator. The derivative is negative 1, is the numerator. At negative 1, so when you subtract the negative, you're adding, so it's negative 1/2. $31. This is it. I thought so. Last one, number 31. I am so under an hour. Which of the following is an equation of the line tangent to this graph? So an equation of a tangent line, the x value, the y value. To find the slope, you take the derivative. That's 2x. And then the product rule. That's the first times the derivative of the second plus the second times the derivative of the first. And then the derivative of 10 is 0. subtract 2x and add 3y to get y prime by itself. Divide, and you get negative 2x plus 3y over negative 3x. Now the point is 1 and negative 3. So 1 and negative 3. So that's negative 2. That's negative 9. That's negative 3. So that is negative 11 over negative 3. So that's positive 11 over 3. So there's my slope. Positive 11 over 3. And there's the one. That's the only one that even has a slope of 11 over 3. If I subtracted 3, then it would match exactly in terms of our HK form. Perfect, right? And that's it. I just did it. That's unit number 3. Mr. G Math over and out. I'm proud of you that you are working at this. You believe in yourself. And practice with me and believing and practicing. We're going to pass the exam. Mr. G Math over and out.